Welcome. Welcome in my talk about bits and bytes. I'm the person holding you from lunch, so bear with me for the next 50 minutes. I will take you to my journey of what I learned from electronics and experimenting with electronics and Java, and how we can take that knowledge into how we handle data. I will be sharing a lot of links, some code examples. You can find everything on my blog, webtechie.be. So if you go to my website, you will find all these links. It feels a bit strange to be talking about ones and zeros at a conference with, what was it, 29 talks about AI. So I have some AI-generated backgrounds. These are bits and bytes flying through clouds and data centers, according to my AI system. What I will explain to you and what I will try to learn to you is how you can use this hex value to be waked up at 6:15. You can see it here on my little friend, my CrowPy, that I will be using a bit later in a demonstration. Also, how we can apply this in Java and how we can use a Java application to demonstrate this. So I will be using some Vaadin and Spring. Oops. The other one is how you can put a smiley face on a display like this, and also with a hex value. So keep the data very condensed and still have the expected results. I learned this when I applied for a new job and started at a new job over 10 years ago. And we were building passenger information system for trains. And we had to visualize, for instance, the availability of toilets in a train. I will be coming back to that later, but actually the value CB, 1 hex byte value, gives us the toilet state of 2 cars in a train. Now all that can be a lesson to reduce the cost of our systems, and not only the cost but also the eco-friendliness of our systems. Is how do we transfer data between systems, and how do we take our responsibility as a developer into account when doing so. To be able to tell this story, we have to go back, way back in time. I'm this old. This was my first computer. I think there are others in the room who had this as their first computer. Oh yeah, older. But at that time, we already had LAN parties even before networks existed, as we know them now, because I was using my Commodore 64 with a relay board to control my Lego train. So at that time, I was already trying to combine software and hardware. My Commodore 64 knew where my Lego train was on the track because I hijacked the joystick ports with magnetic switches. But all that was already possible 30 years ago, 40 years ago, damn. I'm here as presenting software, but actually I did film school. So I'm not a trained software engineer, which is also a bit important in this story. This was where I started my career in this kind of video studio. So I'm even from the analog age. And I moved on back to software, started using Java, and that's when I came up at a company building these systems. Give you more examples later. By the way, Belgian company, San Francisco, Silicon Valley trams have these screens on them. Belgium, made in Belgium. Nowadays, since a year and a half, I work at Azul, being one of the OpenJDK distributors. You can find me and my colleagues at the booth downstairs in the exhibition hall. You may know us from Azul Zulu. By the way, Azul Zulu is one of those few distributions that you can use on many Raspberry Pi versions. So that's also a coincidence that I ended up at this company while experimenting with Raspberry Pis. We already had at the booth a lot of questions about OpenJDK, about distributions, what versions should I use, how should I keep track with evolutions in Java. This is a great book, a book for dummies, it's called, but actually it's for everyone who is interested in OpenJDK. It's by our CTO of Azul, Simon Ritter. And tonight at 5, we have a book launch party. If you want to join us, you can register at the booth, and you can have a signed copy by Simon himself. By the way, Simon will be talking in one of the rooms after this talk. So Raspberry Pi is part of my journey. So a few years ago, I discovered the Raspberry Pi. I think you all have seen these boards in one or another form. It's a very cheap computer which allows you to experiment. And that's what I've been doing the last years, is a lot of experiments. And yes, the Raspberry Pi Zero of 15 euros, which is a quad-core processor with half a gig of memory, that runs Java. That runs Java FX. You can do all the things that you do in your daily job on these boards, with the biggest advantage, if you screw up, you just burn the operating system again on the SD card and you start all over. And you don't need that expensive hardware to do experiments, and that's what I've been doing and what I always also will be using in this talk. Now, I was preparing my presentation. I thought I was finished last week, and then you had this. So there is a Raspberry Pi 5 coming, 23rd of October, which is another evolution. They say they're already working for 10 years on this one, but there's actually, there's more than 11 years of evolution between the first Raspberry Pi and the one that will be released next month. A very cheap, a very affordable way of experimenting with electronics, with Java or any other kind of technology. It's a full Linux PC. Right? You should look at like it. Now, I had an idea. I wanted to create something for my son. This is a Java FX application where I ended up, where he can control several relays, lights. It's connected to an Arduino. The Arduino is connected to LED strips. I wanted to create this. I wanted to use Java because I already knew Java, the language, but I didn't know electronics. So I started experimenting. Oh yeah, by the way, it's a Java application, so that means that there is also an API. And through the API, we can let him know that dinner is on the table. So that's a very easy way. By the way, the video is 4 years old. He's twice as big now. Now, I was experimenting with this. So I started with the Raspberry Pi. I had this experimentation board. I had one component. That component will be crucial in this presentation a bit later, that little display at the bottom. But 6 months I have been experimenting with electronics. What can I learn from it? How are electronics controlled? There are different protocols. We as developers are used to do HTTP calls, for instance, but in electronics there are different SPI, I2C, other protocols being used to transfer data between your system and the components, and what you can learn from these. I ended up with a book, and that's also how I got involved into other technologies and speaking about Java. That's also how I got introduced to 4J. Who knows 4J? Each talk that I give, I see more hands. I like this. 4J.io is a website for the friends of OpenJDK. I think we at Devox are all friends of OpenJDK. It's a community website started by Azul, but a lot of speakers at this conference, a lot of companies are contributing content to 4J. At least one article is published per day. All my content is also there, so if you want to know more about what you can do with electronics, Raspberry Pi, Java, you will find a lot of articles there. And you see that the same technology that we use nowadays just in our job can be used on a Raspberry Pi. I have used Vaadin, I have used JBang, to have single file applications. I have SDKman. I contributed a little change to SDKman so you can have it also running on the Raspberry Pi. And since I joined Azul, I also created 4J podcast. So if you are interested in anything related to Java, you will find a lot of topics there. Like, for instance, how Devox was actually born. That was one of the podcasts. Yeah, you don't have to believe me that it's a great website. A lot of people are telling this, so this is just one tweet I copied very fast. Now, having a blinking LED is the aha moment of programming electronics. It took me days. Having this, so in the background you see Visual Studio Code running on a Raspberry Pi. You see the output. And the button is red, and each time you press the button, the LED blinks a bit faster, and after 5 times, the application stops. This was my hello world into electronics programming. And the whole information about how you can achieve this, we will come back to that, is documented also, of course, online. Now, I started doing talks about this, and I have been traveling with my little friend there, and I was at J Spring, just before summer, and I saw the talk of Holly Cummins, where she was doing a call to Java developers to be aware of how responsible we are as developers, not only for the cost of our system that we create, but also for the eco impact of it. Now, she was so polite, so friendly to let me copy a few of her slides. There's one thing we can conclude. With Java, we already selected a very good language. There is a research project that compared different programming languages to achieve the same result. And C is the benchmark. And you can see in the table that C is the value 1. Java is twice as hungry for energy for a comparable function. The research is a few years old, so I guess things have changed, but keep this in mind as a reference. Python is at the bottom, needs 76 amounts the energy for the same function. So go back to the graph. Now you see what's below there. So with Java, we already selected an energy efficient system. So that's good. Now there are a few other things we need to keep in mind. Who has spun up a server and forgotten about it on Amazon? Which costs you a lot of money. But it's not only money, it's also energy. So you need to keep the thing running. So in a survey, apparently 25% of servers are doing nothing. They are running, that's it. Now of the remaining part, 29% is doing active work 5% of the time. I think there is room for improvement there. The idea here is that most servers are spun up and been over-dimensioned. You don't want to be the developer that killed the system because the server was not big enough. So it would be better if we would be able to measure that correctly and dimension everything according to the right needs. Because, yeah, it's not just money, it's not just electricity, it's also water to cool the whole system, the whole data center, and it's e-waste at the end of the lifetime of a server. If it's never been used, then it's really a waste. Now, bits and bytes, the topic of my story. Through my transition from being an analog video editor to being a Java programmer, I have gone through a whole journey, and I've done web development. So I knew that FF0000 is red on a web page. Now, when I started my new job at that passenger information system company, the first day one of my new colleagues had to explain to me that the FF is actually 8 ones. Who can for sure translate any hex value to the bits and bytes? To the bits. Okay. Because that's something you learn normally if you study software engineering. I didn't do that, so I wasn't aware of the underlying magic. It's actually magic. So for the other persons, I will try to explain it. So if we start with the first one, and everything is based on the power of 2, so the first one is a 1. If we move it, then we go to the 2. If we want a 3, then we have to add 1 and 2. If we want a 4, are you following? Because I found a very, very beautiful movie to explain this. This looks like a perfect weekend project to build. But this is what's happily happening, and you're calculating with ones and zeros. So the basics of computers is here. It's ones and zeros. This goes on and on, so I think I can move it. You get the idea, okay? Now, during my journey and writing the book, I also created some JavaFX applications. If you go to my blog, you check for all the links, you will find the links to the sources of my book, and there are several JavaFX applications there. That's one of them. It's just showing you the same system, and it's a handy tool to learn to work with bits for the calculation. I will not go too deep into this. So, but if the hex value being 1 byte, FF, is actually 8 times a 0 or a 1. That means that we have 8 times a true or a false within 1 byte. Okay, this is clear? So we have 8 booleans in 1 byte, and we can go with the number range from 0 to 255 if we calculate that. Now, how can you know these numbers if you ever have done the conversion from a number to a character? Actually, the whole Latin character set is within this 0 to 255 range. Okay? We will come back to this table also a bit later in the examples. So back to the trains. How is this used here? Actually, a train is a very complex system. There is kilometers of wires in one car. One car costs about 1 million euros. There is a server for the toilets. There is a server for the doors. There is a server for the lights. And all have to know of each other what the status is. If the train is driving faster than 3 kilometers per hour, certain lights have to be dimmed. Or the toilets become available, stuff like that. So there are a lot of different electronics systems from different suppliers, and they need to exchange data. Now, trains go back way long time, so the data that is being transferred between these systems is very small, it's very minimal. And again, we go back to these bits and bytes, showing how many bikes are available in the next station. If there is a toilet in your car, the number of your car, all that kind of information is shared between these train systems just with bits and bytes. Showing where you can find available places, where there's space in the train. And this is just one example of a data sheet. Of course, I cannot share you which train it is. But you see that a bit is used for different sets of different values. Like the train is driving faster than 3 kilometers per hour. That's one bit being toggled in that whole set of data. Now, just let's take a look at an example. We want to show the toilets in 2 cars. So a train has 2 cars. Each car can have a toilet. A toilet can be out of service. It can be wheelchair friendly, and it can be occupied. Now, in this table, we can see that in the first car, indeed, it has a toilet, but it's out of service. In the second car, we have a toilet, it's wheelchair friendly, and it's occupied. Now, all this information fits in 1 byte, CB, 203. The number 203 tells our system all the information we need from 2 toilets in a train. It's character capital E umlaut. That gives us all the information. Now, imagine if we would do that with JSON. We all use JSON, of course. We end up with something like this. So we go from 1 byte, the capital E umlaut, to 245 characters. That's a big impact. That's not only data, that is energy, it's eco-efficiency that gets lost. I learned a lot of this because of using electronics. This little thing, you know it from your alarm clock. It's called a 7-segment display, which is a mistake because it's actually 8 with a dot. So it's 8 segments. It's 8 LEDs. And we go back to that 8 true-false values. So with 1 byte, we can define the state of each of the segments of this little clock component. 6D, that's the value we're going to use. Who can convert this to ones and zeros? Out of the head? Yeah, at least one is to a few. Okay, I help you. This is the value. So this is 109 numeric value. This is a 5. Okay? But that means that every state of this display can be defined with one number between 0 and 255. This is the fun thing if you start doing electronics. This is how the experiment looks like if you go to a breadboard and wires. And what is actually happening here is you actually see the Raspberry Pi on top. There are only a few wires going through this chip. This chip is an I/O expander. So what you tell from the Raspberry Pi to the chip is the 6D. Here is the value. and then the chip will, you see it on the left, will toggle these 8 LEDs on and off. Now I have the CrowPi with me, is another device. Everything is inside there, so you don't see all these wires, but actually that's how you control an electronics component like that. Again, to help you to get all these values, I'm a JavaFX fan. Are there others in the room? Yeah. Okay. We could have a long discussion about the value of JavaFX versus JavaScript, but that would lead us too far, I think. So this is how the 5 looks like. And then by toggling different buttons, you see that we don't leave that range of 0 to 255. So we can define all the different possibilities with just some simple byte values. (6D), 109, 1 byte. That's all we need. Okay? It's the M in this case. The M tells us everything to put a 5 on this display. Now, I've done the exercise again, and this is in XML. It's exactly the same information, but it's 345 characters. Or it's 250 in JSON. And if you have a good architect who wants to use nested JSON, for instance, then you have a bit more. And if you really have a bad architect, then you have YAML, 202 characters. Who is using YAML to send data? Yes, okay, thank you. Nobody is. There's one I want to mention here is protobuffers, which is, I don't think that well known, but actually it's a very good approach. A protobuffer is a text file like this, where you define the structure of your data. You will sorry, you can recognize the values that I was using in the XML and the JSON. But the data that comes out of a protobuffer is actually, in this case, 24 characters. So you create a proto file like this, and with a tool you can convert it to Java code, Python code, C code, whatever. So you can share this proto file between teams as an agreement of how you will exchange data. And it has some advantages. The main one is it's still pretty small, but there is validity checks in there. So if I receive this string, but one of the characters got messed up in network traffic, it will not be able to convert and give you an error. So you know that the data that you received is valid. Not one of the bits got toggled. There's a handy tool online, protobufpal, where you can try this out. So you see the proto file on the left, you see a JSON example on the right, and at the bottom you get the encoded result, and you can go vice versa. Now, LinkedIn, for instance, adopted protobuffer between their microservices. So that had some consequences. One is that the amount of data being transferred is much smaller, but also apparently they got an improvement in latency. So using smaller data is not only from eco-friendly points of view important, but also can improve your applications and your services. I have a small demo here. JDoodle, we just saw in one of the keynotes a playground tool on dev.java, of java.dev. This is another one, JDoodle. It allows you to write code online and just run it. What you see here is the comparison. What I do here is compress a string. That's also a solution you can take to reduce your data. We have the same structures here. I have the XML, I have the JSON, I have nested JSON, I have the YAML here. Now if I run my application, you see the size of the data, and then the compressed string, because that's another solution you can take to reduce your data being sent way and back, but it takes some time. So there's some things you need to consider here before you take this approach. Let me see if I'm doing the right demo at the right time. Yeah, okay, I'm already there. Yep, good. And this gives us these results. So the hex value, of course, it's 1 byte. It stays 1 byte. You have the other values, which are way larger in number of characters for transferring the same amount of data. And then you have the zipped alternative. So that's the XML being zipped. But watch out if you're using zip for strings, because a small string becomes bigger. Zip itself has some overhead. So that's not always the right solution. Bruno Borges, he's here also from Java at Microsoft. He has, if you ever post something about good news of YAML, he's coming for you. He's comparing all the formats. So if you have to choose between JSON, YAML, which has no formatting, which has no support for schemes and stuff like that, or you have to choose for XML, if you stick to these three, XML is the only valid solution, according to him, and many others. I would add protobuffer to that comparison. But the story is, why does data, why does it need to be readable? Why does it need to be readable between microservices? The only advantage I see is if you're debugging something, if you're looking into logs, if you want to see what's happening in a system at runtime live. But systems are just running on their own. They are sharing data between microservices. Why should it be JSON formatted readable for a human being while it's being used by services, by computers, by applications? So somewhere we made the wrong decision of using that kind of data to be exchanged between systems. Another little demo. So if you go back to this same 7-segment device, little display that we have, I have here a demo where I created as a record. And the value is a byte. 6D, number 5, 1 byte. Okay? Then we can just create a record with a lot of helper methods to make it human readable again for the developer. Okay? So we can just ask if each of these components is being turned on and off. And we can just run it. So let's make it a 6D again. And we can make it readable again in the code, in the logging, whatever. But it's only the byte value that we use to create an object and exchange this data. If we go fancy, we can even show it as a 5 in the log, in the output. So if we make it wild, I guess. Okay, we have the dot now. So we can experiment with that. We don't need the whole JSON set to be able to make it readable again in the code. That's what code is meant for, to help the developer build things. Wireshark? No, who knows Wireshark? Wow, okay, you ever tried it at home just to see what is going on your network? Scary, eh? Wireshark enables you to monitor your network traffic, but what most people don't know is you can create your own plugins for it. So if you have a specific data format that you're using a lot and you need to be able to debug it, you can really go on the network and try it out and make it visible again at the bottom of Wireshark, that you really see exactly the same data as you want to see. Now, let's experiment, and that's what I've been doing a lot the last years while writing the book and then later while writing on this Pi4J library. Let's combine Pi4J, Vaadin, and Spring. And a little introduction for Pi4J. I was here before last year talking about Pi4J in 2 talks. So Pi4J is a friendly object-oriented I/O API for Java programmers to access the full I/O capabilities of the Raspberry Pi platform. How mouthful. So what it intends to do is abstract the complexity of dealing with electronics for a Java developer, just in case you want to build something. So it is a library that you integrate in your application. Within the library, there are native libraries which are able to talk different protocols to communicate with electronic components, and it's all handled for you. There is a 32-bit version in the library, the 64-bit in the library. So even on different operating systems, this should work really fast. This is based on GNI. We just heard what a method is. It is so GNI is used in the library. I didn't program in the library. I'm just involved in the project mainly for documentation and creating example applications. But it's really hard. So we're looking forward to all these evolutions still going on in Java, and that will bring us a better system to handle this. As I said, I will be using the Elcro CrowPi. I love this device because it takes away the hassle of all these wires. You've seen all these wires I was using with that little segment display. Within this little device, everything is pre-wired for you. If it doesn't work, you messed it up, not your wiring. So your code is wrong. They have different version of this thing. I have the first one. The second one, everything is hidden under the keyboard. So if you open it, you just see a keyboard, but you can take out the keyboard and you see a lot of components. I always make the same joke. I don't dare to take this with me on a plane. This is exactly how a bomb looks in a movie. Especially if you put on the clock. So someone challenged me of put a battery in there and make it count down and go to there, but no. So yeah, you can do funny stuff with this. But it's designed like the Raspberry Pi originally for Python. So being a Java developer, it was pretty hard to start with this. Now, luckily, students from the FHNW University of Switzerland, 2 students worked for a year, and they create Java example code for every component in this little suitcase. And they added it to the documentation set of the Pi4J project. So, of course, everything is shared on GitHub. As you can see, they have an example app for every component, like for the button, the buzzer, the LCD display, the LED matrix. And the example that I'm going to show, I am a very good developer. That means that I'm a very lazy developer. I just stole their code. No, I used their code to create some applications on top of it. And that's exactly what I invite you to do. If you want to experiment with Java and electronics, is just go grab these sources and experiment for yourself. All these code examples are pre-configured for this CrowPi, but everything can be overridden, and you can specify other addresses if you're using other components or another wiring. I will also be using Vaadin. Actually, as you've seen before, I've a love for JavaFX, but Vaadin is the closest to JavaFX I have ever found to run in the browser. So you can stay in Java code and still produce a web UI. Vaadin allows you to do that. So if you go to start.vaadin.com, the same way you are used to go to start.spring.io, you can configure an application in the web. You can even create some themes. You can add some pages, and you can download it as a zip file, which is actually a full Maven project, a full Maven Spring project. You open it in IntelliJ, you just run it, and you have your application up and running. To be extended, of course, like I will show you, I added the Pi4J stuff in there. Now, in this little demo, I wanted to combine several types of protocols of how electronic components are controlled. So a LED is a digital output. It's just putting something on and off, true or false. The same for the touch digital input, a button. It's either pressed or not pressed. So that's again on and off. But then you have these other protocols like I2C, SPI, PWM, So those are different ways of controlling or talking to electronic components. Let's have a look at the code. I don't dare to do live coding, so sorry for that. I will show you the code. But this is how Vaadin is creating a view. It is like HTML, but it's Java. So you say, give me a header. Oh, it's not really sharp. Give me a header 2, give me a paragraph, and then you can add text and get something from your service and add it to the text. Having an input, like I have a text field, I don't know if you can see it. Let me put it on the side. There's this little display there with 2 rows of text. So I want 2 input boxes for each row. That's what you can do with a text field. You can have a button, and the button then calls a click listener to have something handled by the Pi4J service. So that means that Vaadin takes care of the communication between your UI and the backend. So all within one application. The service, yeah, this is the custom code that I created to add the functionality to communicate with these electronic components. There's a lot of initialization on it. Again, if you go to my website, webtechie.be, you will find a link to these sources. Everything is on GitHub. Let's go to one of the functions. Set a 7 segment. So that's one of these clock elements. So set a symbol on it. Clear these. So you see that all these are talking to objects, Java objects. Let's look at one of the initializers, like the LCD display. You see everything becomes just Java components, Java objects. So each electronic component in this use case is now a Java object, and you can just interact with it like you would do with a database object or any other kind of Java object. Now, where are we finding these hex values back is, for instance, in the matrix symbol. The matrix is this, where you now have the smiley. Those are 8 rows of 8 lets. So again, we have this 8 that we can use, these 8 bits in 1 byte that we can use to define what's being displayed on this matrix display. So if we want a full display, then we have 8 rows of FF, full. All the bits are selected. If you want an empty one, then we have all zeros. And so we have a happy smile and a sad smile, and so on and so on. So all these are defined with bytes. The same is happening with the 7 segment. So we have, again, these 8 bits that we want to toggle on or off. So let's look at it. I always struggle to find back my things. Oops, not show you this yet. So this is the Vaadin application running. It's running on that Raspberry Pi. So we're looking at a Raspberry Pi 4. I think there's 2 gigabytes of memory in there. And it's now using 14 megabytes. So not that much. CPU 1.4. So this is a board of 50 euros running a full Java Spring application. Why would you do that? Because you can. It's probably a bad idea, I don't know, but you can, so I'm using this. And Vaadin is bidirectional, so it's sending information back and forth between UI and the application running it. So if I now go to my touch sensor, which is here, you see that it immediately reacts, okay? So we have a communication back and forth between our device and UI going through a web application running in Java. Okay, let's see. This should do something. I cannot see it myself. I don't know if the camera can zoom in a bit on the CrowPi. So let's go to cross. So you see I can control all these components through a web interface with Java. And here we can maybe learn something. These are the hex values. So if you go to the happy face, this is the value, if you watched really carefully, this is the value I showed you really at the beginning of this presentation. If you go to the 7 segment display, and we show a 5, it's 6D, and these are the bits. So again, we have this one hex value. Oh, this is nice. Maybe I can put it back again. No, you don't see the display anymore. Sorry. Okay, good. Now, I'm going to take a risk, a big risk, because actually, you should be able to do this yourself. So grab your phone and go to pi4j.ngrok.dev. I hate firewalls, I hate setting up rules, so if you have the same feeling as me, go to ngrok.dev. They do the reverse. So the application is making the connection to the outside world. Yep, someone found the buzzer. So what is now happening, if someone can really play a nice song on this, he gets bonus points. So you're now able to control this device and send information to it. Still clear? What you see on the right is the screen of this CrowPi. So you're now, okay, my memory is, CPU is going up, which is nice. We have 217 connections open to the device. Can I please remind you that this is a Raspberry Pi of 50 euros running Java. Help. It should not surprise you that the Java version is Zulu, from Azul, of course. But this is running Java 19. Okay, so you can run everything that you're using in your daily job on a Raspberry Pi to experiment. And everyone is trying to crash my demo, and they're not succeeding. Can I also have a hands of applause for the Wi-Fi? I think I should kill my tunnel. Let's see. Paf. Okay, we're done. You like the demo, I know. But this is the main thing I wanted to tell you. A bit before schedule, but anyhow, is think about the data and how you're using data. That a byte is 8 true false values. 8 booleans. If you need to send booleans between systems, think how you can combine them. Make your data a lot smaller. I'm Frank Delporte. You can find me on Mastodon on fuj.social. I left Twitter almost completely. Think about how you transfer data. Check for the links on my blog on webtechy.be. You can also find all the other articles and a lot of links to related topics. I invite you to visit fuj.io to learn about everything related to OpenJDK world, Java specifically, but also Kotlin, and pi4j.com if you're interested in Java and electronics. And yeah, experiment, fail, learn, repeat, break something. I broke a few of these 7 segments display, by the way, but no Raspberry Pis were harmed during my experiments. And thank you for your attention. I don't know if there are questions. Yes?
I assume that the encryption and the decryption of the data also costs energy.
Yeah.
In which cases is it most beneficial?
I think the question is, how is encryption and decryption costing money? It all depends. We had a discussion yesterday at the booth is about data being transferred between microservices on the same machine, where network is not even involved. So that will also have an impact. Do you need encryption and decryption if you have that kind of use case, or if you're staying within your own system? Can you consider your own system to be safe is also something to consider. In a project before I worked in before, we assumed our system is safe. So between our services, we were just not using any encryption because you can consider it safe if the wall around it is good enough. So yeah, it depends, I think. And doing good measurements. Holly Cummins in her talk, if you look at it, she really did energy measurements on the device. That's also a way that you can measure this, because this is really hard. There are no tools to really calculate this and to really measure this. So it's because this is becoming so important to be eco-friendly, we will see more involvements in this, but I cannot give you any tools at this moment. No, sorry. Okay. Any other questions? Okay, thank you. There's lunch.